Okay, section 2.4 is on page 144. Talks about the derivatives of trigonometric functions. And in this section, we're going to be taking derivative of the 6 trigonometric functions. We need to really establish this identity first. This is something you need to remember. If I take the limit as theta approaches 0 of the sine of theta over theta, I will get 1. Now I want to prove that. So I'm going to make a table and I'm going to pick values for theta. Let me get that in. So I plugged these values in. I checked the limits from the left, the limits from the right. And I plugged it and I made sure that I was in radian mode. And this is what I got. So you notice it's leveling off next to it. Something I should remember. Actually, there's another one. Let me get that in. And it turns out those are the 2 limits that you need to memorize. If I take the limit, as the angle of sine over the angle. So pretty much I'm looking at any time I'm taking the limit and I'm getting the sine of 0 over 0. That's all. And if I take the limit as theta approaches 0, again, a 0 in the denominator, and the cosine of 0 minus 1, that's a 0. Right? So keep in mind, if I put a 0 there, I'll get 1 minus 1, which is 0 over 0. That's always the case. And here, I'm getting 0 over 0 as well. Something I should remember. So now, if I want to derive given f of x equal the sine of x. If I would like to find the derivative of this, f prime of x would be the limit as h approaches 0 of f of x plus h minus f of x all over h. That would be the limit as h approaches 0 of the sine of x plus h minus the sine of x all over h. That would be the limit as h approaches 0, and sine of a plus b is the sine of a cosine of b plus sine of h cosine of x minus the sine of x all over h. And if I continue that, that is the limit as h approaches 0. If I factor a sine of x out of this, actually I could split them up. Yeah, I could split them up. I could split those two up. That's the sine of x cosine of h minus sine of x over h plus sine of h cosine of x over h. So I broke them up by this plus. Here I'll take the limit as h approaches 0 and I'll factor the sine of x out. That's the cosine of h minus 1 over h. And here I'll get the limit as h approaches 0 of the cosine of x times the sine of h over h. And since as far as h is concerned, those are constants, I could drag that up front and say that's the sine of x times the limit as h approaches 0 of the cosine of h minus 1 over h. And here I could do the same thing, cosine of x into the limit as h approaches 0 of the sine of h over h. Now, according to this rule, that's a 1. And according to this rule, that's a 0. So I'm left with the sine of x times 0 plus the cosine of x times 1, which is cosine of x. So if I take a derivative of sine, I get the cosine, and I listed the table for you. If I take the derivative of sine, it's cosine. That's what we just proved. If I take a derivative of secant, that's secant of x tan of x. And if I take a derivative of tangent, that's secant squared of x. Now, if you are to pay attention to those three, and the cofunctions, everything that starts with a C. So whether it is the cosine, the cosecant, the cotangent, they go hand in hand. Sine and cosine go hand in hand, but the cofunction picks an extra negative. The secant is secant tangent, cosecant, cosecant cotangent with a negative. And the derivative of tangent is secant squared, so the derivative of cotangent is cosecant squared with a negative. And that's how you should remember those, and that's how we're going to play all along. I'm going to show a few of those. So I picked the secant to show. Actually, I changed my mind. I'm going to go for cotangent. So the derivative of cotan of x equal negative the cosecant squared of x. Assuming you have those two memorized. So if I want to prove that, I'll take the derivative and I'll write cotangent as the cosine of x over sine of x. And since this is the quotient, oh boy, you see all the fun problems I'm going to do. I would say that would be derivative of the top times the denominator over minus the top times derivative of the denominator all over the denominator squared. Right? And that would be negative sine squared of x minus cosine squared of x over sine squared of x. If I factor a minus out of the top, that's the sine squared of x plus cosine squared of x. That's the most famous identity of them all. And what is that? That's a 1. And 1 over sine would be, and there it is. You could derive all of those. Well, the bottom line is you need to have those handy as you do this homework. Try to have this next to you until you get the hang of this. You need to memorize all of these 6. Yes, that's right. And you're going to memorize a lot more. So, for now, I'll keep a derivative of sine is cosine, derivative of anything with a c picks a negative. On page 150, oh look at all the fun, I forgot the directions. It says differentiate. Differentiate means find the derivative. Oh, I got it right nicer. Find the derivative. Well, if I take a derivative, this requires the product rule. Derivative of the first times the second, plus the first times derivative of the second is negative sine of x, plus twice derivative of tangent is secant squared of x. On a test, this is all I want for now. For the homework, you're going to clean that up. Cosine of x minus x sine of x plus twice the secant squared of x. And that's pretty much it. Now you're going to re-practice what you learned as far as quotient rule and product rule. If you take a derivative of this, that's twice. Derivative of secant is secant of x, tan of x. Minus derivative of cosecant is negative cosecant of x, cotan of x. Ooh. And there it is. So if you get those 6 down, you're in very good shape. If I take a derivative here, that's the product rule. I'll say y prime equal derivative of the first times the second plus the first times derivative of this. Derivative of the second is negative the sine of x. Again, on a test, I'm okay with that. For the homework, that's going to be the cosine squared of theta minus sine squared of theta. You want to match it at the back of the book. And that turns out to be the cosine of theta. On number 12, I need to use the quotient rule. So, if I take a derivative, that's derivative of the top, that's negative the sine of x times the denominator. Minus the top, if I take a derivative of this, that's 0 minus the cosine of x. all over the bottom squared. Again, on a test, this is all I want. But here we're going to clean this up. We're going to distribute. That's negative the sine of x plus the sine squared of x plus cosine squared of x over 1 minus sine of x squared. Y prime is going to equal, this is going to give a 1. So that's 1 minus the sine of x over 1 minus the sine of x squared. This cancels one of those, and I'm left with 1 over 1 minus the sine of x. And if I want to take a derivative of this, I have to kind of think about it as two things. Well, this is how I'm going to do it. I'm going to think of this as one term and this as another. So when I say take y prime, when I say take a derivative of this, that's 2x, derivative of the first times the second, plus the first, and if I want to take the derivative of this, derivative of the first is the cosine of x times the second, plus sine of x times derivative of tangent is secant squared of x. And that's good enough. You could simplify this a bit, you could alter it, you could say tan is sine over cosine, and this becomes x squared sine squared over cosine, whatever makes you happy. All of these will work. The next step problem, well, these are never going to go away. Find an equation of a tangent line, you're going to do that all throughout, and look at that. They gave me an x and a y minus y1 equal m into x minus x1. They want me to find it at x equals 0. Well, what's y prime? The product rule. Derivative of the first times the second. Okay, I can do this plus the first times derivative of cosine is negative the sine of x. Evaluate it at x equals 0. Y prime will equal cosine of 0, which is 1. 1 sine of 0 is 0. So I'm left with 1. There it is, done deal. And the same deal here, y minus y1 equal m into x minus x1. There you go. I want to figure out what the slope of the tangent is at pi. Well, y prime is going to be derivative of the first plus derivative of tangent is secant squared of x. Nice array of writing. Evaluated at pi, y prime equal 1 plus 1 over the cosine of pi squared. That is 1 plus 1 over negative 1 squared. So that's actually a 2. There it is. And that's pretty much what the whole section is about. Last portion of it, number 40 and on. This one, the same deal. Find the derivative. F prime would be derivative of the first 1 over twice the square root of x. Remember we said we were going to memorize that. Times the second plus the first times derivative of the second would be the cosine of x. There it is. Now if I recall that the limit as a approaches 0 of the sine, so as long as I have the sine of 0 over 0, that's a 1, and the cosine will give a 1. So that I know. I want to apply that on the following problems. Actually, I'm going to start that on the next video. It's going to be a short video.